The use of concrete in our modern environment is monumental. It is an essential and ever-present element everywhere we look. The buildings, the bridges, the infrastructure that delivers our utilities to support modern lifestyles, all built with the material that defines construction in the 20th and 21st centuries. But its history stretches back much further, 2 whole millennia into the past. And the techniques on how to create it were lost and forgotten for almost 1,000 years. The legacy of the Roman Empire is perhaps best demonstrated through their pioneering attitude to engineering. Our modern world and the infrastructure we all rely on owes a huge debt of gratitude to the techniques, developments, and innovations that were first crafted by ancient Roman hands. For almost an entire millennia, from 400 BC to the 5th century AD, Rome extended its territories and gained power on a scale unlike the planet has ever seen before, with massive infrastructure projects, military might, and urban planning that would have seemed godlike to the regions they conquered. The Colosseum in Rome, also known as the Flavian Amphitheatre, stands as a testament to their remarkable construction prowess. Completed in 80 AD, its construction began at the time of the Emperor Vespasian and lasted around 10 years, eventually completed under the reign of his son and successor, Titian. This huge structure was built on land that Emperor Nero had taken for private pleasure, and Vespasian wanted to make sure it returned into the public domain. So the Colosseum was designed to become a cathedral of public spectacle and entertainment, like nothing that came before it. Gladiatorial contests, animal hunts, competitive games that lasted 100 days, and mock naval battles were all played out here. 80,000 spectators would watch the greatest shows on Earth in a majestic triumph of engineering, built around a complex system of arches and vaults. At 48 meters high, 156 meters wide, and 189 meters long, it also housed a vast underground network known as the Hypogeum. 2 levels of tunnels and cages where gladiators and beasts would wait before being hoisted up through the floor using elevators and trapdoors to the baying screams and calls of the crowd. The fact that much of the structure remains standing today, after almost 2,000 years, says a lot about the techniques, processes, and materials used in its construction. And concrete literally makes up the foundations that the Colosseum was built on, supporting the vast weights of the structure with amazing durability and strength. Roman concrete was known as opus cementicum, meaning cement work. It was a remarkable material that directly contributed to the strength, durability, and versatility of Roman architecture and engineering. Its earliest uses can be traced back to the 3rd century BC in the construction of harbours, where an incredibly resilient and water-resistant material was essential. And it's likely that the process to make concrete was first attempted in the volcanic regions of central Italy, with one place in particular giving its name to a vital ingredient used. Pozzolana is a natural pozzolan, a sandy and ultra-fine volcanic ash that can be found in huge volumes around the Pozzoli region, close to Naples. Pozzolana was the key ingredient to Roman concrete. Along with lime, water, and aggregate materials such as stones, pottery, and bricks, this could be used to make a hydraulic cement that could set underwater. The lime, or calcium oxide, was produced through heating limestone in a kiln to create a quicklime. When mixed with water, this became slake lime, before adding the pozzolana to make a cementitious paste. The paste was then mixed with the aggregate and poured into wooden forms and molds to make the desired shapes for the structure. Importantly, due to the pozzolanic reaction continuing after the process, it became dense and more resilient over time, especially when seawater was used in the mix. This made it a Roman engineering marvel, and it was duly used in some of the most famous architecture and structural engineering that humans have ever created. It makes up the wonderful dome of the Parthenon due to its light but strong elements. And it holds up the aqueducts that gave Rome access to clean running water to support their huge leaps in sanitation. But then came the Visigoths, the Vandals, and the Huns. The Roman Empire's incessant military campaigns, combined with economic and social decline, ultimately led to the fall of Rome in 476 AD. With it fell so many engineering methods and practices. They remained hidden under the metaphorical rubble of the empire as Western Europe fell into the Dark Ages. Urban planning and construction deteriorated alongside cultural and social development. Cities shrank in size, and construction projects were typically on smaller, agrarian scales. Even during the early days of the Renaissance, construction methods were unable to replicate uses of concrete without the Roman methods to refer to. Lime mortar, a much weaker substance, was employed, and although there was limited use of pozzolans to strengthen it, this was never fully or properly utilized for concrete. That was until 1414. Deep in the library of St. Gall Abbey in Switzerland, an Italian scholar and book hunter by the name of Poggio Bracciolini found a manuscript that would enable the secrets of Roman concrete to be uncovered, over 800 years after they had last been used. The book was De Architectura by Vitruvius, a Roman architect and engineer that had lived in the 1st century BC. This treatise documented a treasure trove of construction methods, techniques, and materials, including the use of concrete, that detailed the very principles of Roman building. The writings of Vitruvius went on to inspire Renaissance architects with a profound impact. People such as Leon Battista Alberti, who would go on to construct such beautiful buildings as the Santa Maria Novella in Florence, began to revive these techniques, and their legacy into the modern world was reinstated at last. It was over 300 years later, in 1756, that the British engineer John Smeaton finally developed a new form of hydraulic lime in his construction of the 3rd Eddystone Lighthouse in Cornwall, England. This is widely referred to as the first instance of modern concrete-like material since the fall of the Roman Empire almost 1,200 years earlier. And, just like in Rome, it was chosen for its durability, setting underwater for marine construction. By the 19th century, concrete was everywhere once again. Isambard Kingdom Brunel was amongst the first to use it on a large-scale infrastructure project, with his Thames Tunnel completed in 1843 that continues to run under the famous river. The decade-long Suez Canal construction from 1859 to 1869 used concrete on its retaining walls that connect the Mediterranean Sea to the Red Sea, demonstrating the immense power and strength of the material. And the enormous Hoover Dam now stands as a monument to the use of concrete in massive infrastructure engineering projects. 221 meters tall, 379 meters long, with a thickness of 200 meters at the bottom, it was created using over 4 million cubic meters of concrete. The Hoover Dam can hold a staggering 35.7 billion cubic meters of water, all made possible with the help of technology created over 2,000 years ago. In the middle of the 20th century, concrete even became an integral part of an architectural style. This was known as Brutalism. The name itself is taken from the French words béton brut, meaning raw concrete. By such luminaries as Le Corbusier in his rough and modular design for the Unité de Habitation housing block in Marseille, France. And also in the exposed brick, concrete and steel of Hunstanton School in Norfolk, England, now a Grade II listed building designed by Alison and Peter Smithson. The cultural impact of Brutalism was huge all over the world. It became the go-to style for municipal, public, and educational institutions that were often criticized for their harsh aesthetic in cities more used to classical and grand architecture. Some argue that much of this criticism has nothing to do with the style at all. It simply coincides with a general urban decay in the latter part of the 21st century. As living standards and environments struggled to progress from the 1960s to the 1990s in much of the world, it was often against a backdrop of brutalist buildings, and the connection and popular culture was fused together. There can be no doubting the environmental impact that concrete has, however. Due to the astronomical levels of use and its incredibly long life cycle, it brings a heavy sustainability burden to construction and infrastructure projects. The production of cement alone, a key ingredient in concrete, is thought to be responsible for around 8% of global CO2 emissions. Then, of course, there is the gargantuan amount of water needed to make concrete, and the masses of fossil fuel used in the creation process. We are so surrounded by concrete in modern towns and cities that the heat island effect, with significantly higher temperatures in urban areas compared to rural counterparts, is also seen a concrete criticism. Along with the habitat destruction and resource depletion of natural sources such as sand, gravel, and limestone, it could be said that manuscripts like Vitruvius's, however unwittingly, have a lot to answer for in climate arguments. That's quite a price to pay for a library book. There are many plans to develop greener concrete for future construction application. Using fly ash, slag, recycled aggregates, and silica fume can reduce the amount of cement used and increase sustainability credentials by a large margin. Combined with more energy efficiency in production methods and the development of significantly more durable concrete to eliminate repairs and replacement requirements, there is a unified goal to make this ancient material more useful in the next century and beyond. For now at least, it provides the very foundation of much of the ground we walk upon every day in our built environments. And in that way, we are following in the footsteps of some genuine engineering gods of the ancient world.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.